The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys. In this video, we're asked to find the half-range sine series for this function. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now what we're going to do is we're going to treat the function as an odd function because we're looking for the sine series. So that's an odd extension of this very function. So what we're going to do is we are going to get started to find only b sub n. So b sub n is 2 over pi, integral from 0 to pi of f of x sine nx dx. So this is what our b sub n is. That's b sub n. Whenever you're dealing with sine series or you're dealing with an odd function, that's the formula over the half range. Now the good thing is this second part of the definition of the function is 0. So we're not going to be using this because the function is 0 at that point. So if you integrate 0, you get 0. So we're only going to be using this integral. We're only going to be using that one. So this will be 2 over pi, integral from 0 to pi. Now, since we're only using this one, we're going to say integral from 0 to pi over 2. Then the f of x sine nx dx. That's what we're going to be having. That's what we're going to be having. So this will become 2 over pi, integral from 0 to pi over 2. Now, f of x at this point is x. So this is x sine nx dx. So this is what we have. That's what we have. So this is x and this is sine x. We have to use integration by parts. So this is 2 over pi. Then I'm going to say write x. There's a shorter way. I don't really write out the formula for integration by parts. It will take me time. So write x, then differentiate this x that you have written down, you will get 1. Now this sine nx you see here, this sine nx, you're going to integrate the sine. Normally, some people will call this di method. Some will call it di method. So di, differentiate, integrate. So I'm done differentiate. Let me now integrate. So this is sine. When you integrate sine, you get minus cos nx over, this is nx. So when you differentiate the nx, you will get n. So you have to divide by that very n. Now this very bracket here, you're going to integrate the gain. So integrating this, you put the minus first. When you integrate cos, you will get sine nx. Now, this nx here, you're going to differentiate the nx to get n. Now that n will come and meet this n at the bottom. So that's n squared. And this is from 0 to pi over 2. All right. So the next thing you do is, this sign here is plus. This sign here will be minus. So it's plus, minus, plus, just like that. But since we don't have a third part, it's only going to be plus and minus. So this will be 2 over pi. Then we have plus times this minus here will give us minus s cos nx divided by the n value will just remain like that. Then minus times minus here will give me plus. Then we have sine nx over n squared. And this is from 0 to pi over 2. All right. So the next thing for us to do is to evaluate our limits. So this will be 2 over pi. Now, anywhere we see s, we're going to be putting pi over 2. So this will be minus pi over 2 cos n pi over 2 all over n plus sine of n pi over 2 over n squared. So this is the upper limit. This is when you put x as pi over 2. And then minus, we're going to put it as 0. So this will be minus 0 cos 0 over n plus sine 0 over n squared. And this part will just give you 0. So you can as well just throw it out. It will just give you 0. So this one is gone. You don't really have to stress yourself about this. It's gone. So this will be 2 over pi. 2 over pi. Then, I kind of feel there's a better way to write this guy. So let me take this over 2 to the bottom. So this will be minus pi cos n pi over 2 divided by this over 2. Let it come to the bottom. So this is 2n plus sine n pi over 2 over n squared. All right. So what I want to do is this. What I want to do next is I want to see the behavior. I kind of know the behavior of sine already. I want to know the behavior of cosine. So we have cos n pi over 2. So the first, let n equal to 1. What is cos pi over 2? That's cos 90. Cos 90 is 0. Let's say n is equal to 2. If n is equal to 2, when you put 2 here, this will become cos 2 times pi over 2. So 2 will cancel at 2. So when you get that, this will be cos pi. Cos pi is minus 1. Next, 3. When n is equal to 3, this will be cos 3 pi over 2. So which is still 0. Then next, when n is equal to 4, this will be cos 4 pi over 2. And when this cancels out, you're going to be getting 1. Now, every single thing I've done here, because you don't have to take note of them. Every single thing I've done here, they are all the same when I start adding 4 to them. They're all the same when I start adding 4 to them. Meaning that this is when n is 1 here, I got 0. When n is 3, I got 0. What this means is when n is 1, 3, 5, 7, basically when n is odd, the value for my cosine will be 0. So when n is odd, cos n pi over 2 will be 0 when n is odd. That's what happens when n is odd. So when n is even, I can either be having minus 1 or be having what? 1. Now, how can I differentiate between these two? And how can I differentiate between them? So when n is equal to 2, it was minus 1. The next time this will be minus 1 is when I add 4 to this. So that will be 6. When I add 4 again, I'll be getting 4, that's 10. When I add 4 again, I'll be getting 14. The value of cos n pi over 2 will be giving me minus 1. Do you know why I'm adding 4? Whenever we have the quadrants, this is the first quadrant, second quadrant, third, and fourth. So there are 4 quadrants. So if an angle is positioned here, for example, let me use here B, positioned in the second quadrant, for example. If I go around from the first, second, third, fourth, fifth, 6 to land here, right? 7, 8, 9, 10 will land here. 11, 12, 13, 14 will land here. So it's like you're adding 4s to it. That was how I got that. Then when n is equal to 4, so the next guy will be 8, the next guy will be 12. You're basically counting in 16s. So cos n pi over 2 will become 1. All right. This is a very, very tedious question. So for the sine n pi over 2, sine n pi over 2. Now to get started with, for this one, to save you the time, for this one, when n is even, is 0. So when n is an even number, you're going to be getting 0. When n is even, your answer will be 0. So sine n pi over 2 is equal to 0. Next, when n is equal to 1, when n is equal to 1, 5, 5 plus 4, 9, 9 plus 4, 13, sine n pi over 2 is equal to 1. Then when n is equal to 3, 7, 11, sine n pi over 2 is equal to minus 1. Now let's come back to this question. This is tedious. When we are done with all of this, we're going to be collating our answers. We're going to be collating our answers. That's what we're going to be doing. So we're going to see how we can use all of these answers to get values for our b. The thing is that some functions, that you can't really get a definitive value for one of the coefficients. So in this case, what we're going to do is to find b1, b2, b3, just like that. Because with the way it's looking, it's not possible to just get one straight answer for all types of numbers, for even and odd. It doesn't exist because they are behaving in different weird ways, both of them. So instead, let's find b1. So b1 means n is now 1 because this is bn. So if I put b1, that means n is 1. So we have 2 over pi outside, 2 over pi. Then let's find the value of this when n is 1. The value of this when n is 1 is 0. It's 0. So it means for this part, everything here will be 0. And then plus value of this when n is 1. When n is 1, value of this is 1. So we're going to be having 1 over n squared. Now, remember that this is n is 1. So let me just put my 1 squared here. So this is 2 over pi multiplied by 1, because 1 over 1 squared is still 1. So this is just 2 over pi. So it means b1 is 2 over pi. Okay, let's find b2. So this is 2 over pi. Now b2 means n is 2. So what's the value of this when n is 2? When n is 2, value of that part is minus 1. Value of that is minus 1. So this will be minus 1 times minus pi. So we have minus pi into minus 1 over 2. We said n is 2, right? So this will be 2 times 2. And then plus. Now what's the value of this when n is 2? Whenever this is even, you're going to be getting 0. So this part will be 0. No need for me to write it. No need for me to write it. Now these two can cancel these two. This pi can cancel this pi. So minus times minus is plus. So this is 1 over 2. So that's my b2. That's our b2. b3 will become n will now be 3. So this is 2 over pi. This is 2 over pi into, now when n is 3, this part is 0. So the cos part will be 0. This part will be 0 because when n is 3, it's 0. Then this part, when n is 3, it's minus 1. So this will be minus 1 over 3 squared. Because we're putting n as 3. We're putting n as 3. So b3 will then become 2 times minus 1. That's minus 2. 3 squared times pi. That would be 9 pi. Because 3 squared is 9. 9 times pi, that is 9 pi. b4. So n will be 4. So this is 2 over pi, open bracket. Now if this is 4, what's the value of this when we have 4? Value of this is 1. Value of this is 1. So we're going to say this is 1. That's minus pi times 1 divided by 2 times 4. Because anywhere you see n, you're going to be putting that very value. Now, what is the value of sine n pi over 2 when n is 4? Now, whenever n is even, sine n pi over 2 is 0. So that part is gone. It will disappear. Now, 2 we cancel out 2. Pi we cancel out pi. So b4 will become minus 1 over 4. So that's b4. Let's find b5. I think with this, it should be sufficient enough to get our Fourier series expansion. So we have 2 over pi. Now, what is the value of this when n is 5? When n is 5, in fact, when n is odd, our cos n pi over 2 is 0, whenever n is odd. So this part will just be 0. Then the sine, when n is 5, is 1. This will be 1 over 5 squared. So this will become 2 over pi, and then we have 1 over 25. So this will become 2 over 25 pi. All right, I think with this, we should have enough. We really don't need to do every single thing. We don't need to do every single thing. So let us now get the Fourier series expansion of this. So I'm going to wipe this part out. I'm going to wipe this other side out. So now the Fourier series of this expansion would be f of x equal to the sum from n equal to 1 to infinity of b sub n sine nx. So that's the Fourier series expansion. Now, the thing is, this would be f of x equal to the sum from n equal to 1 to infinity. Now, b sub n is this weird guy. That's 2 over pi into minus pi cos n pi over 2 over 2n plus sine n pi over 2 over n squared, and then sine nx. So that's what you ought to do. This is how you're going to represent it. So in terms of the summation, this is how it should be. But the thing is, that's looking very bulky. So let's start putting in our values for b1, b2, b3, just like that. Let's start doing that. So f of x will become, so we have bn. So we're going to come back to it. We'll be using this one. So bn, let's start with the first value of bn. So that's b1. Now b1 is 2 over pi. So that's what we have. We have that as 2 over pi. This is 2 over pi sine nx. Then the next value for bn is 1 over 2. So this is 1 over 2 sine, this is b1. So n is 1. So that will be just x. And then this will be plus 1 over 2 sine 2x. Next value is b3. So b3 is minus 2 over 9 pi. So this will be minus 2 over 9 pi sine 3s, because we're putting n as 3 here. We put n as 3. Next is when it's 4. So for 4, we have minus 1 over 4 sine 4x. Then for 5, we have plus 2 over 25. 2 over 25 pi sine, there's no space for that, sine 5x, and then just like that. So if you want to write your answer, this will be how you're going to be writing your answers, and it's still the same basically. So this will be all for this very video. I'm going to see you in the next one. So bye.